On August 15th, 1977, a radio telescope in Ohio picked up 72 seconds of something. Not a blip, not noise. A strong, narrowband signal at almost exactly the frequency scientists had predicted an extraterrestrial signal should arrive on, if one ever did. 3 days later, an astronomer sat down with a stack of printouts, saw the reading, and circled it in red pen. Next to it, he wrote one word: wow. That signal has never repeated. Not that night. Not in the 50 years since, despite thousands of hours of searching. And to this day, nobody, not the astronomer who found it, not the scientists who've spent decades chasing it, can tell you with certainty what it was. This is the story of the WOW signal. Here's what we actually know, what's been ruled out, and why, after half a century, this is still an open question. To understand why this signal mattered, you need to understand what scientists were listening for in the first place. By the 1970s, a small but serious group of astronomers had settled on an idea. If intelligent life elsewhere in the galaxy wanted to be found, or if we simply wanted to eavesdrop on them, there was one frequency that made more sense to check than any other: 1,420 megahertz. The frequency at which hydrogen, the most abundant element in the universe, naturally emits radiation. The logic was simple. Any civilization advanced enough to build radio telescopes would almost certainly know this frequency too. It's not arbitrary. It's universal. A kind of natural meeting point on the radio dial. This search had a name: SETI, the search for extraterrestrial intelligence. And one of the instruments doing that searching was a radio telescope at Ohio State University, nicknamed the Big Ear. The Big Ear wasn't glamorous. It was a fixed installation, essentially a giant reflective dish built into a hillside, and it worked by letting the rotation of the Earth sweep the sky past it, one narrow strip at a time. It couldn't be pointed. It just watched a slice of sky drift by, night after night, and recorded whatever passed through. Most nights that meant recording a lot of nothing. On the night of August 15th, 1977, the telescope was doing exactly what it always did, sweeping its slice of sky and printing out a continuous stream of data. Nobody was watching it in real time. That wasn't how the project worked. The paper printouts would pile up, and days later, a volunteer astronomer named Jerry Amon would sit down and comb through them by hand, looking for anything unusual. The data came out as a grid of numbers and letters, representing signal strength over time. Background noise usually registered as a 1 or a 2. Occasionally a stronger reading might hit a 5 or 6. On this particular printout, Amon found a sequence that read 6EQUJ5. To translate that, the signal started strong, climbed higher, peaked, and faded, over a smooth curve lasting about 72 seconds. The peak value was so far above the normal noise floor that the automated system had to switch to letters to represent it because the numbering scale ran out. It was, by a wide margin, the strongest candidate signal the project had ever recorded, and it came in almost exactly on 1,420 megahertz. The hydrogen line, the exact frequency they'd been watching for. Amon circled it in red pen and wrote "WOW" in the margin. The name stuck. Here's where it gets genuinely interesting, and where a lot of retellings start to cut corners. The shape of the signal is part of what makes it compelling. It didn't spike and vanish instantly, the kind of pattern you'd expect from a brief electronic glitch. It rose and fell smoothly over about a minute and 12 seconds, which is roughly how long you'd expect a fixed, non-moving telescope to detect a fixed point in the sky as the Earth's rotation carried that point through its field of view. In other words, the shape of the signal was consistent with something real, out there, staying in one place, while the Earth turned underneath it. And then it was gone. Never seen again in that spot. Not that night, not in any of the follow-up observations in the years after. That's the core of the mystery. Not that something odd was picked up once. Odd blips happen constantly in radio astronomy, most of them terrestrial interference. What's strange is the specific combination, the right frequency, the right signal shape, an unusually strong intensity, and then total silence, forever, despite repeated deliberate searches of that exact patch of sky. Now here's where we separate the science from the speculation, because a signal like this attracts a lot of the second kind. Was it a satellite or aircraft? Almost certainly not. The frequency band the signal occupied is protected by international agreement, specifically to keep it clear for radio astronomy. Terrestrial transmitters aren't supposed to be broadcasting there, and the signal's characteristics don't match typical satellite chatter. Was it a glitch in the equipment? This is a reasonable question, and scientists took it seriously. But the Big Ear had two separate feed horns, essentially two receivers, and a genuine celestial signal should have shown up in both, just seconds apart. It only showed up in one. That detail has actually been used both ways. Some researchers argue it weakens the case for a real astronomical source. Others point out that the timing and coverage of the two horns make a single detection plausible under the observing setup used that night. It remains one of the more debated technical details of the whole event. Was it a comet? This is probably the most well-known solved-it claim you'll see online, and it deserves a fair hearing. In 2016, a researcher proposed that hydrogen clouds surrounding two comets, 266P/Christensen and P/2008Y2 Gibbs, happened to be passing through that part of the sky in 1977 and could have produced a hydrogen line emission strong enough to explain the signal. It's a clever hypothesis. It's also been heavily disputed. Other astronomers pointed out that cometary hydrogen emissions are typically far too faint to produce a signal anywhere near this strong, and that the orbital positions used in the original claim don't hold up under closer scrutiny. Multiple follow-up analyses have pushed back on the comet explanation, and it has not been accepted as a resolved answer by the wider astronomical community. So, despite what a lot of headlines will tell you, the comet explanation is a hypothesis that was proposed and largely rejected, not a confirmed answer. Was it an alien transmission? Here's the honest answer. Nobody can rule this out, and nobody can confirm it either. A single, non-repeating detection, however striking, doesn't meet the bar for a scientific claim of extraterrestrial origin. Extraordinary claims require repeatable evidence, and this signal has never repeated, despite decades of astronomers pointing telescopes at that exact patch of sky hoping it would. This isn't a story about aliens. It's a story about how much we still don't know, even about our own cosmic neighborhood, and about how rare it is for science to hand us a clean answer on demand. We're not here to solve the wow signal in 12 minutes. Nobody has solved it in 50 years. We're here to show you exactly where the science stops and to sit with that, honestly, instead of manufacturing a resolution that doesn't exist. That gap between what we've ruled out and what remains possible is where real scientific curiosity actually lives. If you want more of these, one real mystery at a time, no filler, no false endings, subscribe. There's plenty more where the evidence runs out.